Hi everyone, so there's no lesson update for today, so we'll be discussing the test that we just did on last Thursday. I think it's good for us to do it now since you still have everything fresh in your mind. Alright, so you can get this set of paper in your drive as well, so remember to do your correction and submit your assignment after that. Okay, so let's try to look at the question here. So number one, part A, the complex number z is defined by this. So find and show your working the two square roots of z. So give your answer in the form of a plus bi. Okay, so when we try to look at this complex number, then you will realize that it's in a form where it's not a plus bi because you have like square root 3 minus I. So the first thing that we need to do is to rationalize this complex number first. Okay, so before you try to do anything, so to you are not confusing in the working. So over square root 3 minus I, so multiply with its conjugate, so we have square root 3 plus I over square root 3 plus I. Okay, so again I want to emphasize that do not skip your steps because I guess a lot of people skip the steps, so that's why you have like a lot of careless mistake. Oh, that's like very common in the class. So when this one is wrong, then which means everything for this question is going to be wrong as well. So 9 square root 3 times square root 3, so we have 9 times 3, which is 27, okay? And then plus 9 square root 3i, the second part, plus another 9 square root 3i, and then plus 9i square, okay? Then over for this part, we know that for the part square root 3i is going to eliminate each other. So that's why square root 3 times square root 3. So we have 3 then minus of I square. Okay, so please remember that I square, I is equal to square root negative 1. So that's why I square is equal to negative 1. So that some people that do I square is equal to negative 1 square, then it will become 1 and that is wrong. Okay, so please remember I square is negative 1. So 27 minus 9, then from there we can get 18, okay, and after that plus 18 square root 3 over I. So this part is the part where a lot of people make careless mistakes. So I square, remember, is negative 1. So 3 minus negative 1, you should get 4. It's not 2. Okay, so after you get this answer, please remember to always simplify your answer first, because in case your other part is wrong, right, then if I were to give you the marks, then I need to make sure that your answer is like simplified over here as well. So make sure that you have a plus I form over here as well before you move on. So 9 over 2 square root 3i. Okay, so now you have this form already, then we can continue with the square root part. So we can let the square root, okay, let the square root of 9 over 2 plus 9 over 2 square root 3i equal to a plus bi. Okay, so yeah, depends on you lah. You do x plus y, I also give you correct. It's basically the same thing. So what do we need to do is bring the square root over the other side, right? So we have 9 over 2 plus 9 over 2 square root 3i equal to a plus bi and then square. Okay, so remember to expand it. Alright, so what do we have here? So a square, and then we know that later we have plus 2abi, right? So plus 2abi and then plus b square I square. Okay, so remember again, I square is negative 1. So that's why when we simplify it, so what do we get here is a square minus b square plus 2abi. Okay, so now we can split it in the form of the real part and the imaginary part. Then we try to do comparison and we solve simultaneous equation later. So the first equation that we have is a square minus b square is equal to 9 over 2. Alright, then after that second part, 2ab is equal to 9 over 2 square root 3 over, square root 3i. Okay, so I think it's easier for us to use this formula to substitute into this equation. So this is like my equation 1. So this one, let us try to change it a bit. So a equal to 9 over. So this bring over become divide. So there's a lot of people you bring here, then it become multiply. Then suddenly it become 9 square root 3. Okay, so please be much more careful in your calculation. Square root 3i. Alright, sorry, there's no I over here. Yeah, there's like 2ab, then 9 over 2 square root 3i, right? So there's no I. Okay, so this is my second equation. Okay, so now I'm going to do substitution. So substitute my second equation to the first equation. So we have 9 over 4b square root 3 square minus b square equal to 9 over 2. Alright, so let's try to expand it. So 9 square and then multiply 3. So that's why we have 243. Okay, then over 4 square 16 b square, then b square minus of b square equal to 9 over 2. Okay, so we can multiply the whole thing with b square, then we rearrange it a bit so to have our b square as positive. So when you multiply b square, then that's one part that you will have b power 4 lah. Then we try to make it like to have non-fraction as well. So what do we get here is 16b power 4 plus 72b square minus 243 equals to 0. Alright, yeah, then after that, let's try to solve this. So either you can try to, if let's say you do not want to deal with like b power 4, then what you can do is you try to let x equals to b square. Then you change it to a quadratic, okay? If let's say when you try to look at this, then you know that this is like your b square, this is like your b, and this is like the one that without any unknown, then you can just solve it like how you solve a quadratic, okay? So when you solve this, then you'll be able to get 4b square minus 9 and then 4b square plus 27, okay, equals to 0. So from here, then I'll have my first part is b square equal to 9 over 4. The second part is b square equal to negative 27 over 4. Okay, so since our b is real, right? So we must know that b is real. So that's why this is rejected. Okay, so we'll have only one answer here, which is b is equal to positive negative 3 over 2. Alright, so after we have found this, then we can proceed to get our a. So a is, let's try to look at the equation. Yeah, so a is equal to 9 over 4b square root 3, right? So you can just solve it by your calculator and you will be able to get when, let me write in pair. Okay, so when b is equal to negative 3 over 2, we'll be able to get a is equal to negative 3 square root 3 over 2. Okay, then when b is positive 3 over 2, so we'll be able to get a is equal to positive 3 square root 3 over 2. Okay, so by having this, remember you should write your answer as the square root part in the real and imaginary form. So the square roots will be equal to a come first, right? So 3 square root 3 over 2 plus 3 over 2i. Okay, and the other one is the negative one, negative 3 square root 3 over 2 minus 3 square root 3 over, minus 3 over 2i. Okay, so this is the question. This is the answer for this question. So I'll just let you know where the marks come from. Okay, so you do rationalize, then you'll get 1 mark. Your last answer is correct for rationalize, that you get 1 mark. Then after that, you try to put them in the same equation and you get these two simultaneous equation, you get 1 mark. Okay, then after that, you solve until the end. I didn't give any solving for this part because it's just basically simultaneous equation. You need to get both the answer here to get the last 2 marks. Okay, so in total, you have 5 marks for this question. Alright, so let's see part B. Okay, part B, I guess this is a question that most of you are struggling with. So there are actually only 1 or 2 people that get full marks for this question. Yeah, but it's actually not that hard. You only need to understand what the question wants. Okay, so I'm sorry that I need to put the diagram beforehand because I wouldn't be able to draw it by using here, and it will be much more tidier rather than I draw it with my free hand here. Okay, so an equilateral triangle has its vertices on circle modulus z equals to 3. So from here we know that there's a loci. So even the question give you the circle already, okay? So it's a loci of circle with center 0, 0, and then the radius is 3. Okay, so by doing that, then you can draw a straight line. So which means that here is 3, then here is negative 3, then negative 3, and then 3. Okay, and for all the circumference, you should have a radius of 3 lah. So one vertex is at a point such that argument of z equals to pi over 6. So this is a loci of half line started from the point 0, 0 as well, and the argument is pi over 6, which is 30 degree. So you can draw the half line. Okay, so by having this, then from here to here is pi over 6, right? And this intersection point is basically our first vertex. Okay, because the point is z, right? So that's why the modulus of z, which means the distance from the origin for z is 3. Then the vertex is at a point that the argument is pi over 6. So that's why this is 3 and then this is pi over 6. Okay, so how are you going to change that? So we know that rather than so the question need you to write in the Cartesian form, right? But we have one form which is called as the polar form. So you can straight away use the sine cos to actually help you to solve this. So we have the formula, if you can recall. So it's z equal to r, then cos theta plus I sine theta, right? So our theta is the argument of the complex number, and the r is the modulus of the complex number. So by looking at this diagram now, we already have these two information. So we just substitute. So for the first vertex, okay, then we already have like z is equal to r is 3. So cos, the argument that we can see here is pi over 6, then plus sine pi over 6. Okay, then just by using your calculator, then you're able to get your first point here, which is equal to 3. Then for cos pi over 6, then you'll be able to get square root 3 over 2. So 3 over square 3 square root 3 over 2, and then plus, so sine pi over 6, then you have 1 over 2. So that's 3 over 2i. Okay, so by having this, you get your first point. Okay, so actually just by doing this, then you have your first mark and your second mark. Okay, so now the third mark, you need to show me how do you know where is your point. Okay, so let's try to look at the characteristic of the equilateral triangle before I let you know why do I not receive the answer that you just try to draw like this, then you say your answer based on this one, because you cannot prove to me that you actually know what's the argument is. Okay, so the idea is that if let's say if this is a equilateral triangle, right? So you can imagine if let's say we try to extend all the line and all these vertex actually meet at the midpoint here. So what is this going to form? This is going to form another 3 equilateral triangle, am I right? So you can see there's a circle here. So definitely because they are equilateral triangles, so this 3 line is going to be the same length as well. Am I right? So what is that cause? So which means you have a circle here. So it's going to separate them into 3 equal angle, which is 120, 120, and 120. Am I right? So that's why by looking at this diagram, so we know that our first point is here. So when you try to draw it, then this is definitely is going to be your middle, right? Because you know that the 3 vertices is going to locate on this circle, am I right? So that's why the center that you are having here is basically the center that you are having here. So it's just that we are going to rotate the triangle a little bit so that it fits onto your one vertices is over here. Okay, so that's why we know that if let's say imagine that this is your vertices, so for you to reach your another vertices is going to be another 120 over the other side, am I right? So that's why for me to draw another vertices here, the distance here, okay, will be actually equal to 120, which let's say we try to change it to radian, then it will be 2 pi over 3, right? So this is how I get another line here. So this is the other point. Is that okay now? Yeah, so it's a bit slanted. Let me try to redraw. Yeah, so which means it's going to be at somewhere here. Okay, because the idea is we know that this is 30 and then you plus 120, then this is going to be 30 as well. So this is pi over 6 as well. Okay, so that's why they should on the same length lah. So from your diagram, right, for you to get the third mark, I need to see this from your picture. Because if you didn't do that, then I wouldn't be able to know whether you are actually just guessing from the diagram that another point is here, another point is here, or you actually know this idea. Okay, so that's the thing that you need to show me. So which means both of them are actually on the same line. Okay, so the other way to actually do that is that you need to write down. So the argument for this line is basically pi over 6 plus 2 pi over 6. So this is for second vertex. Okay, so it will be equal to z equal to the radius is here 3, right, because it's on the circle as well. And then now the argument become 2 pi over 6 plus pi over 6, and that's how you can get 4 plus 1, so 5 pi over 6. Okay, and then plus I'm sorry, I left out the I just now. So sine 5 pi over 6. Okay, so you just use your calculator, then you'll be able to get your second vertex, which is 3 square root 3 over 2 plus 3 over 2i. Okay, which is basically like here. You can see that the distance is the same. So now it's the same thing. So you imagine that this is pi over 6 already. So from here to here, it will be another 2 pi over 3. And this is just nice that the other line would just on the y-axis here, which is this point. So your circle will actually look like this. Let me try to change color again. So the circle will actually look like this. Okay, so this is your equilateral triangle. Is that okay? So you can see this is just like a inverted one. Yeah, so this is like your middle that you have. So you see from here to here is another 120. Okay, so just by using this, then you'll be able to get your third vertex. So which is to get that the argument from positive x-axis to here is negative pi over 2, right? So that's why when you write inside, then it will be z equal to 3. Then cos negative pi over 2 plus, yeah, it's good that you try to make a bracket, negative pi over 2. Okay, so you can just use your calculator. Then from there, for cos negative pi over 2, you will get 0. Then after that, this will be equal to 1, so negative 1 as well. So that's why you can get negative 3i. So this is basically your 3 vertices. Okay, so your second marks will be based on either you need to show me this one or you need to show me 5 pi over 6. It depends on how you answer lah. Okay, then after that, your next one, after if you get that idea, then you should be able to get both. So that's why from here, then you'll get 5 marks. Okay, so that's about this question. So because I am a bit, yeah, I feel like a lot of you actually lost the total 5 marks here. So that's why I actually try to be a little bit lenient, that if let's say you try to draw the locus of the circle and you try to draw this argument and you label the point here, I will give you 1 mark as well. Okay, so that's like the marks if you try to do something with this question. Alright, so that's the part B. So I hope that you can understand. So it's basically locus and then plus a bit of your trigonometry. So that's why when we talk about this chapter, right, actually trigo is very important, because if let's say that's a sketching question as well, so normally they'll ask you like what greatest value of the length or like minimum value for the argument and so on. So those are things that you are dealing with different trigonometry of triangle that you learned before. So that's why you must be very familiar and try to understand it rather than like memorize it. Okay. So yeah, I hope that you get the idea. So the other alternative here is that you can always try to do the art thing as well, but I think it's a bit not not very feasible. It's not very feasible. It's not very helpful compared to this one lah. Because after you do this, then you will need to draw the cosine thing, right? Yeah, but the idea is basically the same thing. You are actually using the R and the data to help you to solve the question. Okay, all right. So that's the idea for part B. So now let's move on to the mechanics question. Okay, number two. So a particle of 6 kg is suspended in equilibrium by two light inextensible strings at angles of 40° and 30° from horizontal. Find the tension in the strings. Alright, so this question initially is 5 marks, but after that I try to adjust the marks from 42 to 40. So that's why I reduced 1 mark. Like I didn't give any marks for the working for simultaneous equation because I guess that should be easy. So I only give marks for the correct answer. Okay, so the first thing, please remember that when the stuff is given in kgs, so this is a mass. Okay, so please do not treat it as a weight. So that some of you actually did this careless mistake. Then second thing is the question gives us that is two light inextensible string. So that's why you have two strings. So that's why these two strings will have different tension. Okay, so that's why in this question you should have T1 and also T2. Then it's at an angle of 40° and 30° from the horizontal. Okay, so now we can try to draw it. So from the horizontal, which means that we can always try to draw a horizontal line first. Alright, then after that the particle is suspended, so 40° and 30°. So that's why it's going to be like this and maybe like this. Okay, so this is 40°. Then this is 30°. Okay, so from the horizontal, right, 40, 30, then after that, this is where the particle is. So it's suspended here. So maybe we have a weight here. Okay, so that's the idea of this question. Alright, so since we have T1, T2, so let's try to label it here. So T1, then this is T2. Alright, so now it's in equilibrium, right? So the idea that we try to do is either you can do left hand side equal to right hand side, or you can do when you find the resultant force is 0. Okay, so let's try to do the first thing first. If let's say we try to draw a dotted horizontal line here, so that will help us to get the angle that we need. So it's a Z here, so that's why this is 30. So this will be 40. Okay, so let's write down some information that we have. So T1, T2, and after that here we have our weight here, which is equal to 60. Okay, so yeah, remember that it's not 6. Okay, so now let's try to resolve in the horizontal component first, because for that one we only have T1, T2, there's no weight involved. Okay, so when we try to resolve in the x direction, okay, then we can get to the left hand side, then we have T1 cos 40. So you should be very familiar with your resolving now already. So yeah, if let's say your problem is in whether you are using sine or cos, you did a mistake there, then please make sure that you try to understand why is that so. Then after that, try to improve from that, because this is very important, because when you move on to other chapters you will still be doing a lot of resolving as well. So it's equal to going to your right hand side, then we have T2 cos 30. Okay, so by having this, then now we will move on to the second one. So this is basically our first equation lah. So if you got this, then you have your first mark. Then after that, when we try to resolve it in the y direction, then what do we have? So moving down, we have only 60. So 60 will be equal to T1 sine 40, and then plus T2 sine 30. Okay, so this is our second equation. So you can just label first one, then second one. So now just solve the equation. So we can straight away just use T2. Let's try to change it a bit here from this one. So T1 will be equal to T2. Depends on you. If let's say you prefer that you want to use the solving the, I mean sine over cos, then yeah, just use that. I mean, don't worry about that. So cos 40. Okay, so from here I get my third. So I'm going to substitute my third one to my second one. Okay, so 60 will be equal to T2 cos 30 over cos 40 sine 40 plus T2 sine 30. Okay, so you can straight away multiply the whole thing with cos 40, then I guess that's easier when we want to solve it. or you straight away, arrange it if you are able to do that. Okay, I think for this one we can. T2, you just factorize everything, right? Bring everything, then move here, then become denominator. So 60 over, so we have cos 30 sine 40 over cos 40. Okay, and then plus sine 30. Alright, so from here then you'll be able to get your T2 already. Alright, so that will actually give you the first answer, which is 48.9 Newton. Okay, so 3SF, but please save this answer for your second one. Okay, so from your equation 3, then substitute your answer, so you'll be able to get, I'm not going to rewrite everything, okay, but it's okay lah. 48.9 cos 30, then over cos 40. So from here, then you'll be able to get your T2, your T1, which is 55.3 Newton. Okay, so remember, answer in 3SF. Okay, so make sure that in your calculation, you are using your full value. So for this question, your first mark, second mark. So for this part is just a basic skill that you should have. So that's why I didn't give any here. Then 1, 2. Okay, so for the total marks, you have 4. So again, I need to repeat, this is a very simple question. So if you have any careless mistake, then it's still fine. But if let's say you are having a problem that you are finding like resultant or so on, that you actually don't understand how to answer this question, then please make sure that you do your revision and try to understand from the lesson again. Okay, so this is the question, this is the part for question 2. So now let's look at question 3. Alright, number 3. So this is a basic question in force and equilibrium. So which means if let's say you have a problem with you don't know how to do in the test, and that's the reason that you lost the marks, it's not because of careless mistake and so on. So please make sure that you really understand the question and do your revision. Okay? Yeah. So let's try to read through the questions. So a book of mass 8 kg is at rest on a rough slope. Okay, so that's why there's friction involved. So a rough slope is 20 degree to the horizontal. So let's try to draw it. So we have the slope here. Okay, so the slope is, let me try to draw it a little bit nicer. So yeah, the slope, then horizontal plane. So this is 20 degree. Okay, so the book of mass 8 kg, let's try to draw the book then. So this is the book. Okay, so the mass 8 kg, so which means that's a weight that acting vertically downwards is 80 Newton. Okay, so because of that is this surface getting touch with the book, so that's why there will be a normal reaction force acting upwards perpendicular from the plane. So this is R. Okay, so when you try to extend this, I hope that you still can recall this. So the angle here is going to be the same with the angle of your slope, which this is 20 degree. Okay, so now the book is held in limiting equilibrium by a force 10 Newton up the line of the greatest slope. So that's why that's a 10 Newton moving upwards. Okay, so find the coefficient of the friction and the magnitude of the contact force. Okay, so this is the part that a lot of you actually either you miss it out or you only treated the contact force as the frictional force only. Okay, so is okay, don't worry about that. Let's try to solve this first. So yeah, because the book is held in limiting equilibrium, right? So that's why you can imagine that the motion of this book is actually going to slip down, right? So that's why to prevent the book from slipping down, so that's why you have a 10 Newton forces that actually held it in equilibrium. So the friction here will be opposing the motion of this book slipping down. So that's why you have a friction that is moving up. Alright, so I hope that you get the idea. So you have actually encountered this question a lot in your exercise and in the handout as well. Okay, so now let's try to solve it. So we can try to find the R first, because we know that when we try to solve friction, that will be mu R, right? And it's easy for us to solve the vertical component first. So resolving to the y direction, or you can just draw resolving like this. So we are going to resolve it on the plane of the slope. Okay, so it will be equal to, going up we have the normal reaction force then equal to the weight. So it's 80 and then cos 20. Okay. So again, there's some people that making careless mistake, or it's like you are not sure that you are doing 80 sine 20. So please see that this component is actually touching the 20 degree here is actually touching the component. So that's why you should use sine rather than cos. So after you get this, then you can get your R, which is 75.175. Okay, so this is like your normal reaction force. So now let's try to resolve in the along the plane. Okay, so we have in this direction. Okay, maybe we can do that direction first, which is much more obvious. Then we have our mu r, right? So which is 75.175, and then plus the 10 Newton, and it will be equal to, towards the other side we have 80 cos it. I'm sorry, that's sine 6, so sine 20 degree. Okay, so from that, then I can definitely find my mu here. So we are just going to solve some max. So you should be able to get 0.231 Newton. Okay, so that's the first part. So remember, contact force consisted of two forces. One is the friction and another one is normal reaction. So that's why when you try to look at this diagram, right, there's this normal reaction here, and then after that, there's the friction here. So what's your contact force? I'm sorry, it's F. So what's your contact force? Your contact force will be the resultant force of these two forces, which is like in the middle like this. So how do you actually need to solve this? Is by using Pythagoras theorem. So contact force is equal to the friction square and then plus normal reaction square. Okay, so from here then you can substitute your friction, which is, I don't think we get the value here, so you can just sub. Okay, mu r square and then plus our r 75.175 square. Okay, so you solve it with your calculator and you will be able to get your contact force is 77.2 Newton. So when you try to look at your working, right, if let's say I try to mark it down C and I put a question mark, which means that you didn't get your contact force. Either you only give me the friction or you actually didn't read the question properly, you only solve the mu, then after that you just move on to the part B. Okay, so for this question you get your normal reaction, you'll get 1 mark. I do not need you to write this value for me since the question didn't ask for R. So when you try to write like this, I give you 1 marks as well. Okay, second marks come from here. So please remember that do not straight away use your calculator and give me 80 sine 20. So if you are lazy to do so, then I'm sorry, I cannot give you the marks. Okay, so remember that all the value that you get from your calculation, you should write it down. The one that you can skip is the one that you do in your calculator. It's not the one that you use your mentality to actually come up with it. So for example, 80 sine 20 then minus 10 and divide by 75.175 is the step that I can skip because that's basically the part of solving, right? So this is the part that I cannot skip because you need to show me that how do you get to all this value. So the third marks here, then the last mark for the contact force. Okay, so now part B, find the largest force up to the slope for which the book remains at rest. Okay, so which means what is this is that the force here is not longer to be 10 here. So I'm going to use the other color here. Okay, so which means this is the force that, the new force that we want to find. So what is the largest force up to the slope for which the book remains at rest? So which means what happened now is that because the friction, the idea of friction you have two. The first one is you prevent the book from slipping down. Then until a certain maximum friction then it's overcome, then what happened is that this force will actually bigger than that. Then what happened of the motion is that you are trying to pulling it up. Am I right? So that's why the largest force that meant by this question is that what is the force that you require so that the slope is nearly at the point where you can actually pull it up. So that's why if the force is big enough to make it in this direction of motion, so that's why your friction will opposing this direction. So your friction here is no longer at this place, but it's in the negative direction. Okay, I hope that you still remember we actually discussed it in the handout already. So part B. Okay, this is A. So part B, so it's going to be the same thing. So what is it different here? It's just that our force here and the R is going to be the same. So the force here, the friction that we have is in different direction. So that's why the force that we have, the new force here, is going to be equal because this is our new force, right? The F here is no longer here. The friction now is here. It's in the same direction with the weight here. So that's why the force will be equal to 80 sine 20, the component from the weight, and then after that plus the friction here. Okay, so the friction is 0.231, and then multiply the normal reaction is still the same. Okay, because changing the force wouldn't change anything in this direction. So that's why you just add them up together and you should be able to get 44.7 Newton. Okay, yeah, so this is how you get to your answer. So this answer should be the one that greater than this out because that's the part that try to just prevent the book from slipping down, right? Okay, so for this question, that is easy for first mark for here, second mark for here. Okay, so yeah, that's the part for question 3. So let's move on to number 4. Alright, number 4. So this is a question under kinematics of motion in straight line. Yeah, so this is actually not a difficult question as well. So yeah, for the mechanics part, actually the question that I think is a bit challenging that I try to put in here is only the 5C. Other than that, it's like pretty standard one. If you remember all the things that we discussed in the lesson, then you should be able to do it. Yeah. Okay, so but yeah, I mean maybe it's a test and you are feeling stressed and so on. So yeah, make sure that you try to improve from there. So particle W start from rest and move in a horizontal plane for 18 seconds. Okay, so we can try to make it like this. So this is like where the particle W started. Okay, so it's actually start from rest and move in a horizontal plane for 18 seconds. So this is like the whole horizontal plane. For the first 5 seconds of the motion, W has a constant acceleration of 1.65. Okay, so it's actually start from rest and having a constant acceleration. So maybe it reach somewhere here. Okay, so we can imagine that from, let me try to write like this. So from the time from 0 second to 5 second, so actually it's moving with a constant A. Okay, so that is important because that's a thing that tell you that you can use Suvat formula from the time from 0 second to 5 second. After that, the W's velocity at time t second after the motion started is given by V equal to negative 0.25 t square plus 4.5 t minus p, where the t is from the 5th second to the 18th second. So you see, when you have this equation, right, then it actually tell you that your velocity actually change according to the time. Then because of you can definitely do differentiation. So as long as you have something to deal with equation, that you need to do differentiation and integration, which means you are having a curve. So if let's say there's a curve, which means you do not have a constant gradient. So if you do not have a constant gradient for your VT graph, then you cannot have a constant acceleration. So only for the time being from 0 to 5 you can use Suvat, but after 5 seconds you should use the formula that is given. Okay, so this is like a 2 stages motion actually. So let's try to see the question. So find the value of P. So this is the value here. So we might need something in common for these two situations so that we can try to solve our P. So the thing that we can see is that the constant A is actually from the 0 second to the 5th second. So after the 5th second, right, when you change to another when you change to another equation, the V that you get should be equal to the V that you get here as well, right? Because this is from 0 to 5, this is starting from 5. So which means that from the constant acceleration, I can actually get what is the V. Then after that, I'll substitute my V here with the time 5 seconds, then I'll be able to solve my P. So how can I do that? So for the 5th second, when t equals to 5, what do I have? So I want to find what is the final velocity, right? Then the initial velocity is start from rest constant acceleration is 1.65, then I need to find what's the final velocity at the time of fifth second. So Suvat formula, v equals to u plus at. Okay, so I can get 0 plus 1.65 and then substitute 5. Okay, so from here then I can get my final velocity is just 8.25 meter per second. So after I got this, because this is the velocity at the fifth second, so which means when I substitute 5 here, it's going to give me the same v. So that's why I'm just going to substitute in this equation. So 8.25 is equal to negative 0.25 substitute 5 plus 4.55, then after that minus p. Okay, so from here then I'll be able to get what's my p, which is 8. Okay, I think that's pretty simple. So let me try to emphasize it again. For this part, you need to write the full value. If you straight away give me the value that you do after your calculation, I'm sorry, I don't give you the marks because you didn't show me how do you get the value. So this is the part that you can skip because what you are doing is solving the equation. So I mean the common scale that is already a basic scale, then that's the part that you can skip. But the one that you are using your information and substitute in your equation, you should show. Okay, so yeah, from here then by substitution and you get 8.25, you get the first mark. Then for you to understand that the velocity when you try to substitute here is going to be the same, you get second mark, then the answer for the last mark. So 3 marks for this question. Okay, so now let's move on to B. Find the maximum speed of W within this 18 second. Okay, so I actually do not sure why is it why your answer is wrong. Okay, so if you can remember when we talk about maximum speed, which we talk about maximum velocity as well, right? That's the positive number here because you can see that what happened for this one is that it's going to be like a curve that moves like this. So that's why when you try to find the maximum speed here, is basically equal to your dv dt equals to 0. And that's pretty straightforward, right? So which means, okay, you see, if let's say you have a doubt that maybe you will say that maybe after this then is the part that is going down, but you can actually find the answer that you compare to this one, then you will be able to know that it's the answer that you get is more than this one. Because if you say after this one then it's actually slowing down, that this is the maximum within the 18 second. If this number is giving you a larger number than that one, then of course that is the one that's going to be your maximum speed, right? So that's why what we need to do is just try to do differentiation from the v equation here. So dv dt, so let's try to differentiate it because we are getting dv dt, right? So to move it in front, so you are going to get negative 0.5 t plus 4.5 equals to 0. Okay, so just by solving this, then we'll be able to get t will be equal to 9 seconds. Okay, so after we get this, the question wants us to find the maximum speed. So we need to substitute back into the equation of v to get our answer. So v is equal to, again, do not skip the step. Please write down everything that to show that you are substituting 9. So 9 squared plus 4.59, okay, minus p, don't forget, minus 8. Okay, so by solving this, then you'll be able to get 12.25. So definitely by comparing this, then you'll be able to know that this is the maximum within the 18 second because it's more than the maximum for the constant acceleration just now. So for this question, then you do your differentiation, you'll be able to get 1 mark. You put it equals to 0, then you get 9 seconds, second mark. Substitute 9, get your last answer, you get the last mark, so 3. Okay, now last one. Find the total distance traveled by W within the 18 second. Okay, so this is a tricky question that I purposely put in here. Okay, so the idea is that I want you to remember that when you try to find total distance, you need to find out where's the position whether your particle change your direction or not. That's the thing that I keep on emphasizing in the lesson, right? Then after that, when you talk about two stages, then you should understand that if let's say the changing direction is happening out of this range, you shouldn't use that t. So for example, like this question. Okay, so I think before we move on, you can see that there's two stages, right? So which means for the first one, we wouldn't be able to integrate this one and get the distance from 0 to 5. So that's a constant acceleration. So we should use Subat formula to help us to solve that. So for the first 5 seconds, so we can try to solve the s that we have. So I think we have ut, yeah. So s equal to ut, u is 0. So t 5 seconds plus 1 over 2. A is constant 1.65 just now, t square 5 square. So from here then we will be able to get 0.625. Again, you should write full value here because this is an exact value, so you should only round it if it's a non-exact value. And this result is going to affect, our last answer. So yeah, later when we get our final answer, then I'll try to talk about this again. Okay, so now this is for the first 5 seconds, right? So our problem here is we need to find out for the variable acceleration time, is there any changing in direction involved? So that's why we know that if let's say the direction in change, the part you will have v equals to 0, right? So that's why we will need to find out when v equals to 0, what's the time. So negative 0.25 t square plus 4.5 t minus 8. Okay, a lot of people do careless mistake when you try to change the sign here as well. So please avoid that. T square minus 4.5 t plus 8. Okay, so from here then you can just change it to a whole number. So t square minus 18t plus 32. Okay, you can straight away multiply 4 and you get this. So from here we can get that t minus 2 and then t minus 16. Okay, so from here we can get t equals to 2 seconds or 16 seconds. So please remember that this formula or this equation only works for the time from 5th second to 18 second. So that's why the change in the direction for the 2 second doesn't matter here, because for the first 5 seconds they are following the Subat that you have here. So that's why for this question the only change in direction that happened is when t equals to 16. So when we want to find our s, let's try to do the definite integral, and that will be much more easier. So we have for the first 5 seconds, we have 20.625, right? Then plus from the 5th second to the 16th second. Okay, it's the time that they didn't change direction yet. So we are going to integrate negative 0.25 t square plus 4.5 t minus t. Okay, then after that, for the second part, because we want to get up to 18 seconds, so that's why the second part will be after changing direction, then from 16 to 18. Okay, and you can imagine that maybe one of it will have a negative value, so please make sure that you are doing the modulus as well. Okay, so I guess the negative part should be for the second part here. Yeah, because eventually this is a quadratic graph, so you can imagine if let's say we try to display the VT graph, right, then how is that going to look like? It's constant acceleration, then reaching the V that we have. Then after that is a quadratic graph, so you cannot have like more than one maximum or minimum point. So the thing is basically it's going to be like this. Yeah, so the part for negative is actually happen here. Okay, so it should be this part you are getting a negative value lah. So it's the same equation V here. Alright, so that's the idea in modulus as well. Okay, so now let's try to solve it. So 20.625. So let's do the integration. So plus 1 divide by plus 1, then divide by the power. So we have negative 1 over 12t cubed plus, so 1 to 4.5 square, so 2.25. Let's try to do all fraction then. So 2.25, when we try to change it to fraction, then it will be equal to 9 over 4 t square minus 8t. Okay, then the number substitute is 5 and 16. Modulus equal to modulus as well, so the integration is the same. 16, 18. Okay, so after that, then let's try to substitute the number. So like what I say, you don't need to write down the whole thing, but it's good that you try to write down the two value that you get after that. So plus, so which means you can substitute 16 to get your number. So that will give you 230 over 3 minus of 35 over 6. Please make sure that if let's say your answer can be written in fraction, so I encourage you to always write in fraction because that gives you a much more accurate number. Then after that plus, I'm sorry, this is not equal to, and plus the same thing, after you substitute 18 and 16, you should be able to get 99, then minus of 320 over 3. So this number should be the same now because this is substitute 16, this is substitute 16 as well. So after that, let's try to solve. So 20.625 plus 605 over 6 plus, this is negative value as predicted. Okay, then our final answer should be equal to 129.128 meter. So again, because this is an exact value, so you cannot round it. So if let's say you only leave your answer in 129, then I'm sorry, that's wrong. Exact answer as if actually you did not round anything. This is basically the value. It's not like it's having like 125.119 blah 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 and so on. So this is the exact value, or a safer one that you can always write it in fraction if you can. Okay, so that's the idea for this question. So let me try to write down the marks that assigned for each of this part. Okay, so if you get for the first 5 seconds, you should use a Shewhart formula to get this number, you get 1 mark. Second mark to identify that the change of the direction. Okay, so and then after that, the next one is after you identify the change, then after that you should have the correct limit, so which means 5 to 16, then 16 to 18. For the limit part, then you are integrating the correct equation, then you get 1 mark. Then the second one is if let's say you are integrating it correct, okay, then you get 1 mark as well. So you are putting everything correctly, so which means you are putting the modulus, then you know which one plus which one, and you plus up these values, so all the whole thing is correct, then you get 1 mark lah, then last answer 1 mark. Okay, so this question will give you 1, 2, 3, how come got 6 1, 2, 3, 4. Oh, I'm sorry, this is combined. Okay, so if let's say you write this, then you only got 1 mark from there, so I didn't give a so which means you actually need to do this, then only you can get this correct, right? So that's the idea. So this part plus this part give you this one. Okay, so 1, 2, 3, 4, 5. So it's 5 marks for this question. All right, so this whole question is 3, 3, 15, so that's why it will give you a total of 11 marks. Okay, so let me try to do a further explanation by putting all this information in one VT graph so you have a better idea, because I see that some of you are confused with the maximum speed. Then you try to use the 9 second when you are trying to find the total distance. Okay, so that actually doesn't matter. Okay, so let me try to show you how this thing looks like. So this is our VT graph. So we have our time, then our velocity, right? So what happened here is that for the first 5 seconds is moving with a constant acceleration. So that's why from here to here is like this. Okay, it's a straight line. So maybe I'm up to 5 seconds. Then after that, I know that this is a negative quadratic graph. So I will actually look at this one, and I know that the maximum actually happened at 9 seconds. So that's why I know that the graph will actually looks like this. Am I right? So this is the part where I get the maximum velocity here, and I have my time, which is 9 seconds. Okay, so this is the part where I start the different stages, because this is the part where I can still use Shewhart to solve it. So that's why 20.265 refer to the area under the VT graph here. So now when you look at the 9 here, right, actually after 9, your graph is still at the positive axis. So that's why you wouldn't need to actually find the limit for 5 to 9 then 9 to 18, because that doesn't matter, right? Because from here up to here is still positive. Then after that, what happened here is until this point is when v equals to 0 when it change direction. So that's why 16 is here. And the graph actually comes down, become negative, right? So this is the part that until 18, which is the end of our experiment here. So because of this part is negative, if you were to do it in one limit, which is from 5 seconds to 18 seconds, then this area is going to deduct off this area. Then what you're finding is like the displacement travel, because they will just take into consideration of the total of this one minus of this one, because this is going to give you a negative value. So that's why to prevent that, so we need to write it in two limit, which is from 5 to 16 to get a positive one. 16 to 18 you are getting a negative one, so that's why we put in a modulus. Okay, so this graph is also to help us to see, you see the 2 seconds that we find here, actually why is that so? It's because of, you see, if I try to draw this negative quadratic graph, right? If I were to extend it here, then this is the part where I actually get the 2 seconds. But it doesn't matter in this question because of from 0 to 5, it should follow the Subat formula, which is under the constant acceleration. So that's why we don't take into consideration for this part. Okay, so that's why the 5 wouldn't actually affect your total distance. That's only the part where you reaches the maximum velocity. Then after that, the acceleration become a negative. So that's the idea for the whole question. Okay, so I hope that you can see the bigger picture here. Okay, so now let's move on to number 5. Alright, number 5, a ball P is thrown vertically upwards from the ground with speed 8.4 meter per second. Okay, so this question is pretty straightforward. So yeah, which means it's just a normal Subat question. So it's thrown vertically upwards from the ground with speed 8.4, so which means initial velocity is 8.4. Okay, so to show that the greatest height, so which means at the greatest height, which is the maximum displacement, which your final velocity is 0. So the acceleration is the opposite direction under the free fall, right? So it's negative of your gravitational acceleration, which is negative 10. Okay, so we need to show the greatest height, which is what's the displacement. So UVAS, so we can always use V squared equal to U squared plus 2AS. So just substitute all the value that we have. So 0 squared equal to 8.4 squared plus 2A and S. Okay, so that gives us that 20S is equal to 70.56. Okay, and just dividing 20, then you can get 3.528 meter, so shown. So it's a very straightforward question. So yeah, just by putting all the values in, you get 1 mark. So show the correct substitution. Again, if you straight away write minus 20s, sorry, no marks. So last one, then after that 2 marks for this question. Okay, move on to B. Another ball Q is thrown vertically upwards as well from a point 2 meter above the ground. Okay, so with speed u meter per second. So the greatest height above the ground reaches by Q is also 3.528. So you can imagine now, if let us try to draw it, this is like the ground that we have, right? So P actually is thrown starting from here. Then after that, this is the point that is at the maximum. So from here to here is like the whole thing here is 3.528 lah, is what we found just now. So now this ball Q is actually thrown vertically upwards, but it's from the 0.2 meter. So which means this is 3.528. Okay, then now this is point P. So we have another ball, which is ball Q. But the ball Q doesn't start here. The ball Q start at 2 meter from the ground. So which means maybe somewhere here. So from here to here is 2 meter. Okay, and the question tells us that the greatest height above the ground reached by Q is also 3.528. So which means this is the maximum point for Q. So that's why by looking at this diagram, then what is the maximum displacement that taken by Q? So it's actually 3.528 minus of the 2, right? So that's why the U is what we want to find. Okay, then after that, A is equal to negative 10 as well, because you are trolling it vertically upwards also. So final velocity is also 0, then the maximum displacement that it has is actually 3.528 minus of 2. Okay, then from here, then you'll be able to get, yeah, so we can actually rewrite it later. So v squared equal to u squared plus 2as also, but it's just that we need to find our u now. So 0 squared equal to u squared plus 2a, then our s is 3.528 minus 2, which gives us 1.528, sorry. Okay, so from here then we can get that u squared is actually equal to 30.56, which our u is equal to 5.528. Okay, yeah, so remember that we are using like going up as positive lah for this question. Alright, so for your 2 marks here, then it will be 1 mark substituting all your correct value, which means to identify that your S is 1.528. Then after that, your last question, your last to show that this is right. So 2 marks. Okay, so let's look at C. So this is a question that, yeah, I'll agree that is a bit challenging, but as long as you understand what the question asks, then you actually should be able to understand it. Okay, show that at the instant where P and Q are at the same height, the particles have the same speed and they are moving in the opposite direction. Okay, let's try to draw a diagram here. So it's going to be the same thing like our part B, but yeah, let's try to do that again. So we have on the ground, we have this particle P, right? Okay, then after that, for the particle P, we know that the initial velocity is actually equal to 8.4. Okay, then after that, we have this second particle, which is particle Q here. All right, so the difference between the P and Q is that particle Q actually start from 2 meter above the ground. So the U is 5.528. So this is the two information that we can have. Okay, now when the question said at the instant where P and Q are at the same height, the particles has the same speed and moving in the opposite direction, it means that you need to prove that at the instant where what is the time when the P and Q are having a same height. Okay, you see I'm writing height of P equal to height of Q. I doesn't write displacement. Later, let me try to explain it why. Okay, so which means there will be a time that the height of P and Q is the same, and we need to show that at that time, their speed is the same but moving in a different direction. So which means when that's it having Vp, that's going to have V or negative Vq. So that's the idea, right? Which means, for example, 1 and negative 1. So which means same magnitude and different sign, which means different direction. So that's what we want to find. So which means by having the same height, we can find the time. So by looking at the time, then we can find the speed. So we prove that they are having the same speed. Okay, so now let's try to solve the first thing first. When we say that P and Q are at the same height, does it mean that the displacement is the same? So the idea is it is not. Because why is that so? Because is that you can imagine when we say the displacement is the same, right? Which means, for example, if P displaced for 1 meter, then Q is displaced for 1 meter as well, right? Because their displacement is the same. So what happened here is that Q is here, P is here. Are they at the same height? They are not, right? When we try to compare at the same height, which means that we are looking at the position. But our problem with displacement is that displacement always tell us what is the final position when we try to compare to the initial position. And the initial position of P and Q is different. So Q is always 2 meter higher than P. You get what I mean? So that's why we cannot say that displacement of P equals to displacement of Q. Because when I try to talk like that, then they will never be on the same height. Because if let's say their displacement is the same, then definitely Q is always higher, 2 meter higher than that. Okay, so come back to this. So if let's say we try to compare the height, what is the important thing that we need to know? Is that we need to start from a same position. So how do I measure the height? I always measure the height from the ground level, right? So that's why this is 0 meter. So let's try to do this. What we want is the height of P is the same with the height of Q. Okay, and how are we going to relate it to the displacement? Because we still need to use Subat formula to help us to do that. Okay, now let's imagine if let's say this is the distance where P move, so what is the height of the P? It's the same, right? Because we are measuring from the ground and P is actually moved from the ground as well. So the height of P is actually the same thing as the displacement of P. So now the problem is actually Q, because Q actually started at a point above 2 cm. If let's say, sorry, 2 meter above. So that's why if let's say this is a displacement of Q, what is the height? Is it the same? So, okay, let me try to give you an example. If let's say the Q actually displays for 1 meter, so what is the height now? It's not 1 meter, right? It's 1 meter plus 2 meter. So that's why the height of the Q is actually the displacement of Q plus 2. Okay, so I hope that you can get this idea why do we need to do so. So now by having this, then we can solve our equation inside here. So what we have is SP. So how can we actually solve for SP? So we have U, we also have our acceleration, which is constant for both, which is negative 10, right? Then after that, we have T, then that's the variable that we need to solve. So which means by using S equal to UT plus half AT squared. So let's try to do for SP first. So the U is 8.4, then T plus 1 over 2 negative 10 and then T squared equal to SQ. So SQ is 5.528 T plus 1 over 2 negative 10 T squared, and we have the plus 2. Okay, so it's continue from there. So now let's try to solve a bit of the equation here. So you can see that T squared is going to be eliminate each other. So we can have 2.872T equals to 2. So by solving this, then we can get our T is equal to 0.6964 seconds. Okay, so we can write in more significant figures. So please make sure that you store your value in your calculator, yeah. So which means that at the time when T is equal to 0.6964, they are at the same height. And when they are at the same height, the particle actually have the same speed and moving in the opposite direction. So which means now we need to find what is the final velocity when the time is 0.6964. Okay, so which we can try to use the equation of V square as well. So we have U and A, right? Then after that we have T. So we can use V equals to U plus AT. Okay, so the final velocity for particle P is equal to U plus AT. Okay, so we can just write down our final number in 3SF. So from that we can get 1.44 meter per second. Okay, so same thing, the final velocity of Q at the instant. So I'm sorry, so it's 5.528. I think for this one it's important. Make sure that you store the value, because if not, you will get one as 1.44 and the other one is negative 1.43. So make sure that you got all the exact value. So negative 1.44. Okay. So if let's say you want to write some explanation, then you can just write that particle P and Q is having a velocity with the magnitude is the same and it's different sign. So it indicates that they actually move in the same speed but in different direction. Okay, but in this question, I actually do not check much on that. So what is important for me is you know how to write everything here. So which means you are writing the whole thing correct, then you will have 2 marks for here. Okay, then after that you actually get the T 1 mark, then you prove 1.44 negative 1.44. Okay, so that's the 5 marks for this question. So the whole question here will give you 9 marks. Alright. Okay, so yeah, that's pretty much for the discussion today. So I hope that you can understand and try to improve on that. If let's say you have any questions, so feel free to let me know. I mean, whether from personal chat or tomorrow morning during your M1 consultation hour or S3 Wednesday consultation hour. Okay, so that's it for today's session. Thank you.